Yeah, so as Marcelo said, no one really has issues with working with legacy code because everybody is lucky enough to write new applications from scratch with the latest technology. So, as Marcelo said, people call me Super Marek. That's a handle you can find me on Twitter. I'm a software engineer at SymfonyLabs UK, which is part of Invika Group. And that's what I'm doing on my actually day-to-day work is I'm working with legacy applications. So this is what I would like to share today with you. So before we start talking about how to fix legacy, I would like to say a few words about what we mean by legacy applications. Because that's what different people have different idea of how to approach it. So the easiest way to talk about legacy applications is what is legacy code? It's someone else's code. I didn't write it, so this is legacy application for me. You can always say that your code you've written a couple of months ago, a couple of years ago, you consider legacy because you don't remember what's going on there. The code might be written with a framework you don't know, so you treat it as legacy. Basically, you don't want to touch it. You're afraid to touch it. It can be application which is built over years by different people using different techniques and mixing different styles, ideas, and so on. The code might be not up to today's standards. Most of it is procedural. There is no object-oriented programming concepts. There will be no namespaces used. There will be no clear code convention. So it's going to be very difficult to go through for you, being used to things like PSR. So legacy code may also mean things like PHP mixed with HTML, overusing global variables, abusing them actually, changing get values during your code execution, stuff like that. So you may also have like inc files in your public folders, which someone forgotten to protect from being accessed through the web. So your business logic and how your application works is leaking outside. Your legacy code is usually very difficult to debug. There is no concept of environments. There is just probably a zipped copy of production, and all logging is disabled because on production it would take too much space and slow down the web server. So there is probably no version control used. But the most important bit about legacy code is that it has no tests. So if you try to modify behavior of any part of your application, then you're being afraid that you're going to break something, you don't know where. So you probably need to employ like a team of QA to go through your application click by click and check if everything is still working after you've changed behavior. So yeah, it's very difficult to understand add features. There's no documentation, so basically you're afraid to touch it, and you don't really want to work with it. So how do we get out of this situation? How do we try to work with the code which no one really wants to work with? So before you actually start writing code or changing anything in your application, try to figure out why you want to change it. Try to define the clear goal of your of what you're trying to do, right? If application is in production and works and provides you some income or provides you some services for other people, you don't really want to change it drastically. You don't really want to throw it away and start from the scratch. Some companies are lucky enough. I remember my builder had like 6 months to rebuild the whole application from scratch using the new framework. You don't usually have this luxury. So when you start talking, and ideally you should start talking to your people who are stakeholders of the application, try to identify goals. So this is kind of the reason why you want to change your application. The reasons might be different. It might be you want to improve conversion of the site, so you get more sales, and that equals to more income. You may, for whatever reason, you have a huge dropout at checkout because you're missing some information, and you would like to change that as well. Or maybe you just present some weather information to your visitors on your website, and you would like to keep them longer. You would like to reduce the bounce rate. So if you keep them longer on the page, if they keep browsing, then that means they see more adverts, and if they see more adverts, you get more income. So when you define your goal, then you should start thinking of actors who can help you to achieve that goal. And thinking of actors, think of people who are using your website, who are using your application. If it's a web shop, you're going to probably have some people who are just browsing and window shopping. So probably you will try to, you have researchers who are looking for specific information. You may have people who are coming from your newsletter and they keen to buy something. So there are different type of users, different types of actors trying to access your website. The same if it's just information type website, like displaying a weather forecast or like weather averages for next couple of months. There might be users who are considering going on holidays and showing them adverts of airline tickets or hotels might encourage them to click, and you get more income from that. So you can also have like internal users, people operating like shop owners or shop assistants who would help to process your some orders or stuff like that. So try to identify your actors. When you identify your actors, then try to see how they could impact your goal. So let's say in your online shop, let's say you have a legacy application, a small online shop which sells some postcards, and you display the price of the postcard, but you don't display the postage, how much that's going to work. So a customer who's going through the checkout, they may not be happy that they don't know yet how much they're going to be charged. So that may be encouraging them to not to buy from you. I actually know the real life example. There was a web shop selling little model planes. For years they struggled because they didn't have a clear postage policy. For many reasons, mainly because when you place the order, usually the products were not yet in stock and they were arriving at the different times, so they were shipped as soon as possible. So it was very difficult to estimate the postage at the point of placing order. But that was also affecting the sales because customers would go somewhere else when the postage was displayed and they knew exactly how much they're going to pay from the start of placing an order. So when you have your goals, your impact defined, then you should define your deliverables. Clearly state what you can do to to achieve your goal. So, for example, with the same example with a web shop displaying a postage, it's gonna give the shopper information how much the total is gonna cost, so they can make a better informed decision on whether they want to buy from you or from someone else. So when you have your deliverables defined, then you should prioritize which deliverables you want to work on first, which ones they have bigger impact on your goal, may have bigger impact on your goal, or maybe there are some quick wins which are easy to implement and may help you achieve your goal quicker. So when you define your goals, you have a why, which is, in this example, reduce your dropouts by 10%. You have who, an actor, which is your shopper, and you define how, seeing the total cost of the order. You know what to do. It's what show the postage information or postage cost on the checkout. So this is how you read it, and this example can easily become your definition of your feature. And when you have a feature, you can start writing scenarios. For each feature, you're gonna define scenarios and to support that feature. So usually don't stop with one scenario. It's better to have try to capture many edge cases of your typical user, and having clearly written scenarios like that may help you to work on the project better, to build the deliverable. So now there's a tricky part. Some of your code is going to be already implemented. So when you write scenarios like that and you use it with Behat, you may want to build the existing functionality you're going to change, cover with tests. So this is going to be, how to say, basically don't try to touch stuff you don't going to change in your application. Just try to cover with tests the stuff you're going to change. There's no point of touching stuff which already works and we're not going to change it at all. So your scenario should only focus on the deliverables you want to achieve. So my preference to write code with legacy application, there are two tools, PHP Spec and Behat. PHP Spec is a powerful tool which helps you design code through specification, which gives you two side effects. You end up having documentation, which is easy to read, and unit tests, which cover your objects. Behat is a Cucumber-like tool, which works with feature files written in Gherkin. So it basically allows you to test, to convert a scenario like that into acceptance criteria for your application, for your acceptance tests. So you can slowly, you can test your application on like a business logic level. So this is basically, the Gherkin is following 3 steps. It's very simple. Gherkin language is very simple. It has 3 keywords: given, when, and then. Given is just like a prerequisites for your tests. So if you have a Behat step to implement this step, it's going to be like setting data in a database or preparing the environment to execute some action. When is the action which is actually performed by the actor, and then is the outcome we're expecting. So in the Behat step, that's going to be probably assertion if we're seeing on the page what we wanted to see, or if the information is displayed the way we want. So when we write our feature and we execute bhat, it's going to fail because no code or test is implemented. So we start with implementing our bhat steps within bhat. The next step is to write failing tests in PHP spec, or basically write specification for your basic objects. And then the next step would be to implement the specification. So you end up having this loop: write code, write test, write code, refactor. And you should repeat that loop as long as it's necessary to build all the objects, little units of your application to support the feature you've just created. If it's a legacy application, you may need to refactor some of the existing code in the application, but you're only touching stuff which is related to this feature. And until you get your test pass, your bhat scenario pass. So these are actually two awesome loops. The small one is test-driven development, right? So you write test first, then you implement your code, your test. You write code to pass the test, and you refactor. The second loop is the BDD loop, which is a behavior. You describe behavior with your scenarios, and you have them implemented by your code. And I would say this is actually showing you external and internal quality. Your tests, unit tests, are basically just for yourself, because that's ensuring that your code is doing what you expect it to do, while your external quality, your feature files, your scenarios, it's what you agreed with your business owner, with your stakeholder, how you want your application to behave. So this is what your business owner can relate to. This is the code which ensures that you do stuff, your application works the way you want. So you're going to ask me what to test. I'm going to say you everything. Everything what you can. At some point, you may find out that there are some parts of the system you don't want to test because it's not necessary. But I always tell everybody that you should test as much as you can. The more you test, the better. You get to the point when you may decide that you're not going to test value objects because they are too simple. But the more you test is the better. And there are different types of tests. As we said, you have a unit test which cover your code at the object level. Then you have acceptance test, which cover your application on a business logic level, I would say. And then you have integration tests, which check how your application integrates with infrastructure, whether it's database or API or even UI. And a smoke test is like checking the website and everything, all full stack is working. There is also it's a human test. So from time to time, you really want to see if the application is really working. Because you may find yourself that you can write application. You can actually deliver a lot, only looking at the acceptance and unit tests, and then someone else is doing front end. So you may want to see how it all works together. So at different levels, we use different tools to automate it. The only level we can't automate it is the manual test to check that everything works. But for unit tests, people usually use PHP unit or PHP spec. They very similar, so we do the same almost. bhat is used for acceptance tests. Sorry. So these are your stories. Then you have integration tests. My tool of choice is PHP unit. You can use Behat for that, but I prefer to use PHP unit. And then you have a smoke test. You can automate them, and you can use same Behat scenarios for smoke tests. Just mark them as critical in your suite, and don't execute all tests on UI, because they're gonna be too slow. So if you look at that again, it's from different perspective, from the speed. The unit tests are the fastest. They should be executed in seconds. Same about acceptance tests. Testing your business logic should be really fast as well. Then your integration tests are going to be slower. So you don't really want to test the full stack application every time you test everything, because it's going to be slow. If you just focus on testing application at this level, where you have database integrated, all APIs integrated, the tests are going to be slow. And I've seen applications where there's like 120 Behat steps, and it takes 10-15 minutes to execute them. And another application where there's like 6,000 Behat steps and takes less than 30 seconds. Okay. So why you should test? Why should you test? Tests provide you with code level documentation. If you use PHP spec, it displays nicely in a pretty formatter all tests which are passing. You can read that and you know exactly what the object is doing, even without looking at the object's code. The same with feature files. If you just want to have a rough idea what your application is doing, you read through the feature files and you know exactly what your application is doing. It works as a documentation for you. It also encourages you to write clean code. If you have complex classes objects which require many dependencies, many objects, then it's going to be very difficult to test those classes. And if they have any hidden dependencies, it might be impossible to test. I've once seen someone who didn't test the class. I asked, why didn't you test the class? Oh, because it's too complex. So you should focus on writing tests first. Don't try to write it after the code is written. And this way you kind of force yourself into writing clean code. Otherwise, if you write your code first and then try to test it, then you end up mocking like a zillion of dependencies, and you spend your time mocking after your test is done. So yeah, that's what I said. Oh, and also tests give you another good thing. When you want to change a feature, when you want to change an object, executing the full test suite, which tell you exactly where the problem is and what's affected, and you can fix issues within minutes, not days. Also, that also translates into number of features which are delivered on the project. The red line shows the typical legacy application, which at the beginning you can deliver many features very quickly, because application is quite small and everybody knows how it works. But over time it becomes more and more difficult to add new features, to the point where it's almost impossible to add anything new. If you write clean code and test it, then your pace of adding new features should be quite stable. It's going to be slower at the beginning, but over time, on the longer projects, it's going to be a win. So, okay, now we get into Symfony Components. Why use those? Symfony itself is a full-stack framework, which helps you build powerful applications from the scratch. But if you already have an application, or Symfony itself is just a collection of components which you can reuse as you want. You don't always need, you not always need a full Symfony stack. Sometimes you just need a couple of components from it. Or if you have an existing application, you may just use a couple of components which will make your life easier, but you don't really need to convert your application or rewrite your application with Symfony framework. So yeah, Symfony components are fully tested, decoupled, easily reusable, and de facto becoming a standard inside the community. Many projects are using them, including other frameworks like Laravel and Drupal and Easy Publish. So yeah, using Symfony components, you can try to build your micro framework, or you can use components you need inside your application. The choice is yours. It depends how your current application is built. Everything is well documented on the Symfony site, so using any components is fairly simple. I'm going to show you a couple of examples, which I've used in a couple of recent projects. So the most important component, which I usually add as first, is dependency injection. Dependency injection, because I want to have a standardized way or like an easy way of application to build dependencies and objects for me. I want to have an easy way to configure it and just get what I want, and then dependency injection will look after it for me. So dependency injection, the dependency injection component is fairly simple. But before I start talking about it, I want to talk about another feature, which I believe Kacper is going to talk a lot about on next talk on this. It's dependency inversion. So imagine you have a postage calculator object, which depends on a postage repository. So this is a direct dependency. Postage calculator needs somewhere to read from the postage per number of items or whatever we defined it. But what if we wanted to replace it with something else? If it's a implementation, we can just change it to be an interface. So suddenly our postage calculator relies on just interface, which using dependency injection we can substitute with different implementations. And that's very powerful, especially when we talk about tests. If we're building an application and we want to quickly test our application, we don't really want to spin up the full doctrine in Behat scenarios. SQLite or in-memory repository is going to be much easier, much quicker, and it will allow us to test the full stack application within seconds. We still want to test it with doctrine, probably as a smoke test, but doctrine is going to be a lot slower, and accessing real database is going to be a lot slower, so we probably want to execute a couple of tests with that, and the rest with something simpler and quicker. So how we install the dependency injection in your application? It's just use Composer. It's de facto standard for managing if your current application doesn't use Composer, just create the Composer JSON file and start using it. It's as simple as that. You can even do it with Drupal 7, which has no idea of Composer. Just start using it next to it. Then create a container.php file. That could be wrapped in as a kernel class. Then it's OK. So it's just a simple file which will load configuration and expose container for you. So if it's a legacy application, probably you will need to inject your container to that. So let's start. You can use, even if your application is not using namespaces, you can still use namespaces in just one file to define what you want to use. If you started using Composer, then you have to add autoload. So any classes which are, any code which is loaded via Composer will be accessible for your application. Then you create a new container, add configuration, services configuration through the YAML file loader, and compile. And container basically is your access to the clean code inside your legacy application. So services YAML, very simple. We have a postage repository which is implemented by postage SQLite repository and postage calculator which takes the repository. So it's a very simple example, but it shows you that dependency injection already is doing something for you. So if you take the postage calculator in your application, you don't have to care how to compose object and how to inject dependencies to it. To use the container in your code, just require it next to other requires you have in your legacy application. Get your object you need from container and do whatever you have to do with it. Very simple. Dependency injection with Drupal 7. You can do exactly the same. Container, the difference is use the Drupal root variable and set it in the global variable, and that's it. Then in your Drupal 7 module, you can just access the same, your decoupled code, and execute what you want to execute, action. So another cool thing I would like you to start using with your legacy application is Twig. And it's very simple. Twig is an awesome templating engine, and I haven't seen anything better yet in PHP world. And it's very simple to start to add to your applications. Just require twig. How to use Twig? You have to tell it where you have templates, create an environment, pass the Twig loader file system, and here we go. You can render your templates with data. Very simple. So how to, having dependency injection included in your application, how do you add it to DI? Simple. Parameters, add a service, another service which takes the other one. And you can, inside your application, you can have some. Yeah, you can take renderer and render some data with the template. Very simple. And you don't have to rewrite the whole application. You can render bits of code, bits of templates, or you can render the whole pages. It's adding console commands. Again, very simple. Require Symfony console, having some command, which is a like Symfony command. Just register it as a service and create app console file as an executable. Get a container, register your commands, and application run. And you can have as many commands as you want. Using the dependency injection will build everything what you need for it. And that's it. Decouple from global state. This is the thing which annoys me a lot when someone is trying to change the global variables. So yeah, use HTTP Foundation. You can use it. You can use it by basically in your application in files. So HTTP application flow is very simple. You have a request, it gives you a response, and it's handled by some kind of controller. or application kernel, which delegates that to Symfony. What Symfony does is it matches the root and delegates to the controller, which is assigned to that root. But in our application, legacy application, we don't have to go through the whole kernel. We can just do it inside your application. If you have some index.php, require container, create a request from globals, get your controller view, pass request, you're going to get response, and send the response to the browser. That's it. So very simply, you can decouple bit by bit without doing the revolution in your application. Going forward, you find many more other components you would probably like to use. There's plenty of them. I also have a exercise which I created for the workshop. This presentation was done as a workshop at PHP Summer Camp a couple of weeks ago in Croatia. So if you want to try it, there are 4 exercises, and I built a legacy application. The slides will be shared on speaker's deck, so you don't have to copy it now. So yeah, basically I built a legacy application which step by step is migrated to a better Symfony-like application using Symfony Components. That's all. Any questions?
Thank you. As you're adding more and more of the Symfony components in, how easy is it, if you've added enough of them, to actually turn it fully into a Symfony application? What's the missing bit once you've added in almost every Symfony component to turn it fully into a Symfony application, and how easy is that? Well, it depends how you're
how you progress with your move. But if you go towards like having basically this decoupled from a global state where you take requests, pass it to the controller, and take the output as a response, then you can basically move this controller into application, into Symfony, define routing to match that controller, and you're done. So that would be fairly simple.
There's a question, please.
Then one back.
Here's a question to do with, you said not to write tests for code that you've already, only write tests for the new features that you're building. But if you do that, how do you get confidence that you're not breaking anything?
That's a tricky one. Sometimes you, well, if you're touching a feature, then I would write at least some smoke tests to see that the state before the feature was added is working the way I want. And the code you cover, then it should be covered with features. If you start with a smoke test, you know the initial state is working the way you want. But as soon as you start changing it, you're going to refactor the code behind it. So suddenly your code becomes covered as well. Does it make sense?
Well, I still feel like you'd have other areas that you might break that you don't. You wouldn't have no idea that you could break them.
Yes, you still, if your application is really coupled, you still might have some other bits which are affected. And if you have a legacy application, then you still need to spend time having a manual test for the application and fix it as you go. Because those bits will affect, your changes will affect probably other changes as well. So I don't think there is another way to avoid it.
There are a couple of ways you can sort that one out, if I may.
Excuse me?
There are a couple of ways you can actually start to get some tests sorted. Even just sort of a UI-driven test to make sure the thing as a whole still returns something sane. And then when you do come to actually editing the code, you put a test in there, but the test is going to fail because you have no idea what it does. So you put some values in there, figure out what it does, and then you rewrite that test to say, if I put these values into this function or class, it gets these numbers out. So that's more of an investigation, but then you've also now just written a regression test. So if you're editing that code and that test breaks, it's changed, and it's probably changed for the worse because things are now changing underneath you, where you should just be refactoring cleanly and just cleaning the code up.
There's a question in the back.
At the back there. Yeah. Hi. You talk a lot about sort of tests, and forgive me if you've explained this bit, but are you trying to tell us that we should go back and on legacy code and add in tests to everything? Because that can be more investment in time than it would take to refactor a lot of it, and you could, or just rewrite it with tests in the first place, and you at least then have ownership of the code and you know what it is. And how would you sell that to a business when you say, right, we're going to spend the next 2 months writing tests for this, and you're not actually going to get any improvement on the code?
Well, I wouldn't write tests for existing code base. I would start writing scenarios and like acceptance criteria, which are discussed with the business. So this is where you start. You start discussion with the business. You write stories. You write examples. You ask your business examples how your system needs to, how the part you're going to work on is going to behave, and then you change only what you have to. You cover with tests only what you have to achieve those scenarios. So if you have a website which presents products and does other stuff like waitlist, wish list, favorites and stuff, and you just want to cover a basket with your changes, you don't gonna write tests for wish list.
So just new functionality?
Yeah, new functionality.
But the main talk is dealing with legacy systems, so that's well.
Yeah, but whatever works, and you don't have to change it, leave it as it is.
Is that clear? If it's not, you can talk to Marek at the next break. He's going to be here for the rest of the conference. We're going to need to have a break now for the next speaker because he's going to start. He's here to set up. Please give a round of applause to Marek. Thank you, Marek.